So let me see if I can do this right. And well, it says it's recording, so we'll see what happens. If there's a disaster, then we'll find that out later. Calculus is a really exciting topic. If you looked at the syllabus, you'll see I mentioned it's in many ways kind of considered the really supreme intellectual achievement of the human race. So you have kind of hit the top here when in your calculus course. So I hope you're excited to learn about calculus. It's a lot of fun. Don't be intimidated by it. Let yourself enjoy it, because it really is a terrific learning experience. One thing I can say about calculus is, in taking calculus, is you're going to feel yourself get intellectually stronger through the semester. You're going to feel like a stronger person at the end of calculus. That's what's really so exciting and invigorating about the subject. So I hope I can teach it in a way that you feel that that pleasure and that invigoration that comes from learning calculus. We're going to go through here at the start all of the rules, of course, for the course. So we're going to talk about syllabus and how the course is going to work. All right, so that's going to be a little bit tedious here at the start, but we have to get through all of that. Okay, but then we will get into today the initial notes on calculus. And we're going to take it right from the beginning. So I'm going to start with really elementary topics or concepts that you need to be familiar with to understand calculus, particularly in terms of terminology. But these things are going to be things that you're familiar with. So so it's going to really be a review, and so you're going to feel like, oh, you know, I know this already, and you do. And and that's fine. Okay, it's meant to feel like a review. I just want to make sure that we understand all of the you know, the key, again, terminology or key concepts that calculus is built upon. But you have explored those in your prior math classes, right? All your prerequisite classes building up to calculus. So this is a lot of review. However, in doing the review, I'm going to sort of start introducing notions of calculus as part of the review. You may not notice that, but at first, but when we actually get into the calculus, then you'll start seeing why I was talking about these review topics the way I was talking about them. Okay, so I did mention in the syllabus a little bit about what calculus is about. It's hard to do justice to calculus, of course, in a paragraph, right? So any sort of brief description is not really going to capture the true importance of the subject, but or the true flavor of the subject. But calculus has two main parts, and the first part is called differential calculus. And the second part is called integral calculus. At the beginning of the course, our key focus is going to be on, and for 2/3 of the course, our key focus is going to be on what's known as differential calculus. And in differential calculus, what we're going to be studying is two quantities that are related to each other in some way. And it may be just some physical means by which they're related, or they might be related in a more abstract way, but two quantities that are related to each other. And what we're really interested in learning about in calculus is how one of the quantity changes when the second quantity changes. Okay, so we want to understand the relationship or the nature of the change in the quantities, right? Again, when one quantity changes, how does the second quantity change? Okay, and so that's really the key topic of differential calculus. Now, in the last part of the course, we're going to study what's known as integral calculus. With integral calculus, it seems like a completely different focus. In integral calculus, the key there is we're going to take some large quantity that's difficult for us to measure. For some reason, it's hard to measure. It may be just physically difficult to measure it. And we're going to learn how to measure that quantity that's difficult to measure by breaking it up into little tiny pieces, very, very small pieces that are much easier to measure for some reason. Okay. And so we measure the little pieces of the big quantity, and then we add up all those small measurements to get a measurement for the large quantity. Okay, notice that seems like a completely different idea than differential calculus, where we're studying the change or the relationship in the change between two quantities. Okay, but it turns out that those two problems are actually closely related to each other, and this was the great insight of Newton. Actually, Newton's teacher understood this, and but Newton developed the relationship between these two ideas much more fully. Okay, so that's why he's credited with sort of founding or inventing the subject of calculus. Now, what makes calculus though really cool is the following. For instance, in the integral calculus, when we talk about breaking a large quantity up into smaller quantities, what gives calculus its power is we're going to think about when we break those little pieces up into infinitely tiny pieces. Okay, and when we're studying in differential calculus how one quantity changes when a second quantity changes, we're going to be thinking about how do those quantities change when the changes are infinitely small in one quantity. Okay, so calculus really explores sort of this idea of infinitely small pieces or infinitely small changes, infinitely small changes in quantity, or breaking up a large quantity into infinitely small pieces. Okay, so that's really the power of calculus. And when we get to that idea of infinitely small changes or infinitely small pieces that we're going to break a quantity up into, that's when you'll start really feeling like, wow, I'm learning something really exciting here, right? I'm really sort of expanding my consciousness, or expanding my intellectual powers here, my intelligence a lot. Okay. Now, I did want to say more about Isaac Newton before we get into the dreary part here of going through the syllabus, because I mentioned Isaac Newton's teacher had really developed some of the basic ideas of calculus, and then Newton developed those further when he was very young, about your age, actually. Newton was in his early 20s, about 21, when he started developing calculus. And what happened was there was a plague. Okay, so there was a plague in England in 1666, if I've got the year right, or 1665. And Newton was at Cambridge, and much like University of Houston downtown, Cambridge had to close. Okay, well, of course, they didn't have online learning in 1665, so Newton had to go home from Cambridge, and it was during that year that Cambridge was closed. That's when Newton really developed a lot of his important ideas for calculus. Okay, so there was a relationship between the founding of calculus and you're learning calculus right now. They're both happening during these plagues. One comforting fact to know, of course, is that, well, Newton didn't succumb to the plague, right? But also this plague in 1666, that was really the last major plague in London. Okay, there had been many plagues in London prior to that. They happened periodically, okay, quite frequently actually, but the one in 1665 or 1666 was the last major one. This was when I say plague, I mean bubonic plague. So hopefully this coronavirus that we're living through now will be a last episode like that for at least a long time, right? Okay, we'll all be relieved to know that. All right, so I'm going to again, so far y'all are behaving really well. So many of you have muted yourself, so I haven't really had to mute everyone. So we'll see if I have to do that. I'm going to switch to screen sharing now, so we can start talking about the sort of the details here of the class. Do y'all have any questions, though, that you want to ask me at the moment about anything? Again, I'm going to go through all of the nitty gritty here coming up on the syllabus. So anything, so you can just unmute yourself and ask me, or you can chat. Oh, I do have a question here. What if you work and you can't join lecture? Okay, so I'm recording the lecture, right? Okay, Melissa. So I will try to post those to YouTube, and the link will be on the Blackboard page. So I will show you where on the Blackboard page the link is. So I hope you will be able to come to lecture, though, because we will be doing stuff in class, okay? And so I think attending lecture will be useful. So do try to attend. But if there are instances where you cannot come, we will again, they'll be posted. So we'll see how good the recording quality is. Okay, I haven't tested this. All right. Okay, here's someone that was in my pre-cal class. All right. I think there may be a couple of people who've had pre-cal with me. So if you've had me before, good to see you again. Good to have you back. All right. Let me now try to share the screen, and let's hope this goes well. Sometimes, you know, this is tricky, right? So let me hit share. All right, so is everyone sort of seeing that? Hope so. Okay, so let me find what I wanted to start with here, and that is the that is the syllabus. Okay, let me see if I can get this out of my way so that we can go through some of the key things on the syllabus here. So so this is posted on the Blackboard page, so I hope everyone has had a chance to log into the Blackboard page. I'll show the Blackboard page here in just a second. All right, but before we get to that, let me just run through here some of the key things on the syllabus. So everyone made it here today, so you know what time it is, right? And you know how to log into the Zoom, right? So that's pretty easy. I will be having office hours, so the office hours will start on Thursday. I'm not going to hold them today, but they'll start on Tuesday and Thursday, starting on Thursday, and the time will be at 1:30 to 2:30. So I will try to be on Zoom at that time. It's the same ID and the same passcode, right? Okay, as you're currently used to. And so just log on there starting Thursday if you need to see me in my office hours, and I'll be available. I can also meet you at other times by appointment if these times are not convenient. So there is my email. So you can email me, or you can message me through Webassign. So when we get to the Webassign homework portal, you'll see that you can message me through Webassign, right? So that's how you can contact me. Here's just the description of calculus, right, that I've already sort of gone through. I do want to reemphasize that I'm really pleased to be working with everyone this semester. Okay, really happy to be teaching the class and getting to know you, and learning, helping you learn calculus. And we'll be learning together, because I learn something new every time I teach calculus also. Okay, although I've done it many times. So I learn something new too when I'm teaching it. There's just the description of what calculus is all about. So I already mentioned that, so you can read back through this. Here are the learning outcomes. So I have to post these on a syllabus, right? These are the things that you're supposed to be able to do when we finish the course, but these are not going to have much meaning to you right now, so I'm not going to go through those at the moment. But those are the official things that we want you to be able to do when you get finished with the class. Now, some people have already asked me about the book, so here's the book. It's called Calculus. I think it's the 11th edition. Now, you get access to the book, though, when you purchase access to what is known as Webassign, right? That is the online homework portal for the class, and I'm going to show you that here in a little bit. So the a textbook, an e-copy of the textbook comes with your a copy of Webassign. It does have a cost, though, so that's not free. And so I know that can be burdensome, but this is a really important part of the class. So you will need to purchase access to Webassign. The online cost is $100, but if you pay $125, you can get multi-term access. So if you're going to be taking Calculus 2 after this class, if that's part of your major, then if you pay $125, you can use the book again. You don't have to purchase access again for taking Calculus 2 or Calculus 3 for those of you who may be required to take Calculus 3 as well, if that's in your degree plan. Now, so however, you can, at the moment, you can log into Webassign and create an account and use Webassign for, I think, 2 weeks. All right, so you have a 2-week grace period starting today, I believe. So the class is open. I noticed some of you have already registered. So you do have a 2-week grace period. So you don't have to come up with the money immediately. And if you work ahead a little bit in the homeworks, then you really have even a longer period before you need to actually purchase the access, right? Okay. But again, the online cost is that's $100. All right. Let me in a minute here, we'll look at Webassign, but there's the address. There's the website. Notice it's webassign.net. And when you do enroll in the class, you have to have this code, right? That will get you enrolled in my class. You used to have to know the school zip code and the institution ID, but I don't think you need these anymore. If you already have a Webassign account, however, though, of course, when you first use Webassign, you have to create a username and a password. I think the username is going to be your email address, and the password, of course, is whatever you like. But if you already have a Webassign account, if you use that, for instance, in your pre-calculus class, of course, you can use the same username and password, but make sure that you enroll in the class with this ID. So you will show up on my roll book in Webassign. I keep all of my grades in the Webassign grade book. I don't keep them outside of the Webassign grade book. So that's another important reason why you need to enroll in the class, and eventually you'll have to purchase access, right, to stay enrolled in the class. You only need this number once. Once you get enrolled, then you won't need this number again. Of course, you need to keep track of your username and password, though, right? That you'll use to log on each time. Again, there is the Webassign location. Notice that's .net. I think this is the same. They've changed the owners, but I think this is the same. If that doesn't work, you can easily find Webassign just by Googling it, though. Okay, so so this is a really important part of class. Again, I'll show you this I'll show you this Webassign there in just a second. So, but please try to get enrolled since you've got free access now to start with. Please try to get enrolled as soon as you can, because I've already got homework posted. All right. Okay. And so we want to get working on that right away. Okay. In terms of help with the class, I'm going to mention this more a little bit later. There's the Math Center. They have online appointments. So I maybe mention that on Thursday, so we don't waste time talking about that today. However, I did want to point out that we have in this class, so we have a special feature in this class, right? So you're really getting your money's worth in this class. And we have an SI leader who is kind of the personal assistant. I don't want to call her assistant, but she's the SI leader. So she's kind of an added bonus to this class, and her name is Madison, and I'm going to let her introduce herself right now. So Madison, will you talk to the class?
Sure. Can you hear me well?
I can hear you fine. Can everyone else hear
Awesome.
Madison? If not, let us know. So
Okay, well, I'm gonna go ahead and introduce myself. Hello, everyone. It's nice to meet you guys. My name is Madison. Like Professor Waller was saying, I am an SI leader. Have any of you guys had an SI leader before in any of your classes? Yes, okay. So for those, awesome. For those of you who aren't familiar with having an SI before, basically SI stands for supplemental instructor. I'm kind of like what Professor Ball was saying. I'm open to anyone who needs help with calculus outside of this class, but the special thing about this class is that all of my activities are based around how Professor Waller teaches it and exactly what you guys are going over or have gone over already. So it'll be specifically revolved around your class. And I'm here to help you guys with calculus. The reason I do this, kind of like what Professor Baller was saying earlier, there's just those like moments where understanding calculus like really gets you. And I really want to help you guys kind of reach that feeling and that moment of just aha. I want to help you guys with that. And so I'm super excited to meet you guys and to work with you guys this semester. I will be posting something, an announcement on Blackboard about when I will be holding those session times and some other ways to contact me and all that stuff. So, yeah.
yay! Oh, okay. All right. So these sessions that Madison is going to have, these are really nice, and so I'm really encouraging attendance for Madison sessions. Okay, you're really going to find that helpful, particularly for answering homework questions, right? And but also for learning the concepts better, so that you will be ready to take tests. Okay, because a lot of the questions on our tests, a lot of the questions on your homework are sort of procedural questions, right? So they're grinding through algebra and so forth, right, to get answers. But a lot of the questions for the tests are going to be more conceptual, and so Madison will be able to help you be ready for those conceptual type questions, right? Because they may feel a little bit different from the homework questions. All right, don't worry, you'll be prepped well for those. Okay, but one of the ways you get prepped for them is through Madison, right?
Oh,
Okay.
yeah. Can I add something real fast, Professor Waller?
Yes.
Sorry, I forgot to mention. Yeah, so Professor Waller saying how I can help you guys prep for exams and stuff like that. So I have regular 1 hour sessions twice a week. Like I said, I'm going to plan those days with you guys. But I also have 2 hour exam reviews. So where I specifically go over things that will be on the exam, and I'll help you guys with all those procedural things and understanding those conceptual problems a lot better.
Great. Okay. So I highly recommend that. That is very helpful. Students who go to SI really find that beneficial, and it shows up in their grades, right? Okay. I think most people have attended already, so some of these policies here are just university policies that don't need to go through. If anybody needs special accommodations, though, be sure to contact me, right, about those, right? So let me know. You can email me. Usually the university will email me as well, right? But make sure I'm aware of those, okay? I do want to go through some of the classroom expectations, though, right? Just so that we can make sure that we are adhering to the rules. I am going to be looking at attendance, right? So I will be observing attendance, and we do have an attendance policy, and that is don't miss more than 4 class periods, right? I'll explain what the penalty is for that. So we have a leeway here for 4 class periods, but if you're but I don't want you to run over that. So please try to come to class, because participating in class is going to be very beneficial to your learning, right? Of course, you don't want to miss tests, okay? So our tests will be take-home tests, so it's going to be hard to miss them, because you have a window there to take your tests and submit them, but you don't want to be missing tests, right? Because that's going to go down as a 0. So be careful of that, unless you have some sort of a good excuse, right? And please try to notify me in advance or as soon as possible if you're going to miss a test. Otherwise, I will have to give you a 0 for the test. We will have homework again. As I mentioned, it's online through Webassign. I will have specific due dates. So we already have due dates for the first couple of homework assignments, which are really pretty easy assignments to start with. Well, when I say that, they're supposed to be easy, but they're not new material, but maybe they won't be always so easy, okay? But they're not new material anyway. However, if you are late with an assignment, you can request, by the way, when you're doing your homework, as you're doing it, every time you complete a problem, you get credit for that problem immediately. So it's not like you have to do the whole homework and then submit it. So your score is constantly updated as you finish problems. But if you don't have a score that you like on a homework assignment after the due date, you can apply for an extension, and you get an automatic 2-day extension of homework. But you have to apply for it, but you get it automatically. So here are the instructions for how to apply for an extension, so that you can continue working on your homework. You do have a little bit of a penalty there, though. You're going to lose some points, okay? Do I explain the penalty there? I'm not sure if it's explained there. Oh, it says half credit. That's not quite correct. You get 60% credit for the points you earn after the due date. So the points you accrue after the due date, 40% of those you will lose, right? So it's a little bit better than half credit for after the due date, but you do have to apply for that extension if you want to keep working for that. Okay, but normally homeworks are due on a given due date. Here's how your grade is going to be. Here's how your grade is going to be. I'm just looking at your chat windows there. Okay. Here's how your grade is going to be calculated. We do have 3 tests, right? Okay, so those are just old-fashioned written tests. They're not multiple choice. As I mentioned, they're going to include procedural questions, right? Just rote questions, but they'll also have some conceptual questions as well. So each one of those is worth 17% of your score. So altogether, that's like 51% on your tests. Those are going to be take-home tests written, right? So what you will do is I will post the test, and then you will write your work, and then you'll email that back to me in PDF form, right? And then that's what I will grade, okay? So, and you have a 1 or 2 day window to return that test to me, okay? So, like I said, it's hard to miss a test because it's not like you have to sit and take it immediately when it's posted, right? We will be having some class activities, so class participation will be important. So that's just 7% of your grade, right? And then we have a comprehensive final exam. I just saw that the day of the final exam is May the 11th, so we have a long time to think about that final exam. And this will be comprehensive, though, right? And it will be a take-home final exam, just like the midterm test. So I forgot to mention, did I not put it in here? I forgot to mention homework is worth, there it is. It's scrolling past me quickly there. Homework is worth 17% of your grade. So that's equivalent to a test. So your the major components of your grade are going to be the homework, the 3 tests. Those are all the same, 17% each. and then a final exam, which is 25%, right? Okay, so slightly more than the midterms, all right? And your grades are computed in the, your final letter grade is computed in just the normal way, right? 90 to 100 would be an A, 80 to 89 is a B, and so on and so forth, correct? Okay, so hopefully no one will be below 60, so we won't have to worry about this category at all, but below 60 is going to be an F. And I record all the grades in Webassign in the online gradebook. So in Webassign, you can find your grade. Okay. All right. If you are going to have to, for some reason, drop the course, you have till May the 5th. So you have a really lenient window here for dropping the class. So if you drop by May the 5th, you'll just get a W, right? But if you run past May the 5th, which is actually our last class day is May the 5th. So you've got a long time to consider dropping. But if you go past May the 5th, you'll have to take a letter grade. Okay, so if for some reason you stop attending for whatever reason, I hope you won't, but if you have to for some reason, make sure you drop by May the 5th, right? Okay. Here's our brief online schedule. So I don't really need to go through that in detail. We may stick to this closely, or we may get behind schedule, or I may vary this a little bit. This is just what I proposed so far, but I'm hoping that on February 25th will be our first test. So this you can probably count on. Our first test will be February 25th, right? So we still have a month to plan for that, but just be thinking about that already. And then there's important university dates. As already mentioned, our final exam is going to be May the 11th, and our last class day is actually May the 4th. That's a Tuesday, I believe. Okay, so we have a long time to look forward to that. Do y'all have any questions? You may be safer unmuting yourself than chatting with me if you can unmute yourself. But any questions there on how the syllabus is going to work? I think it's pretty straightforward. Okay.
I had a question, sir.
Yes.
So you said all our grades are going to be posted on Webassign.
Yeah.
Does that mean none of our grades will be accessible on Blackboard?
Yeah, your grades won't be. I'm not going to try to link the Webassign and the Blackboard gradebook. So yeah, everything will be in Webassign. And we'll take a look at Webassign here right now, so you'll see how that. Well, there's nothing in there right now, so you. But you'll see where you can look for your grade. Okay.
Okay. Thank you.
Yeah. So it's, and Webassign updates like every day at 6 a.m. So your grade will be very current. All right. But your grade in Webassign really is kind of meaningless until we get to the first test, right? Okay. It'll have your homework scores until February 25th, but it won't be until later, right, that we get until that first homework, it's going to be kind of, until that first test, it's going to be kind of, not really that useful. Okay, other questions there about?
I actually had a question.
Yes.
So I was trying to log into Webassign
and
enter the class key or course key or whatever, but it says that it's invalid. The key you gave us is invalid.
Oh, okay. So, well, 6 people got on. So did anyone else have trouble with that?
Yeah, I did put UHD at the beginning. Should I not?
Let's try to do that and see. We'll try to do that right now and see if and see what happens to us. But I hope, does someone have that key written down? Because y'all have to tell me that when we try that. Okay. All right. So we're going to go right to Webassign, but other questions before Webassign? Just other questions about other things right now?
Sorry, one more question.
Yes, please.
After your exams, like, do you do the recording thing and we have to record our tests and then send it to you, or is it just on our own time?
No, I didn't understand your question. So say that again.
Sorry, just exams, are they proctored where we have to like record ourselves taking exams and send it to you, or is it just on our own time?
Yeah, no, they're not proctored, right? Yeah, okay. So yeah, they're not proctored. So what happens is I will post them in Blackboard, and then you know, and you don't even have to really download the test. You can just read the test off of Blackboard. You can write on a separate sheet of paper. That's fine. And then, or if you want to, you can print it and write on the test. And then you'll scan that to PDF, right? And you can use your phone to do that. And there's instructions for how you can do that. And then you just mail it back to me, right? By the time. Yeah. So I don't, I don't try to proctor you. That's really way too complicated. Okay. So that's how it works. Yeah. So that's really pretty easy, I think. The only part you might have trouble with is converting things to PDF. If you haven't done that a lot, but that's easy to do with a phone. You know, once you've done it once you've got a little practice, and then just mail that back to me. Usually don't have issues with that. But I do want to caution you, but this is in the instructions, so we'll have time to talk about this. Some people like to take pictures, you know, of their tests and email me the pictures back. That you cannot, unfortunately, do because the picture files are huge and I cannot write on them. So, or it's harder for me to write on them. So you do have to convert to PDF. But again, that's easy. If you can take a picture, you can convert to PDF. Okay, so we got plenty of time to deal with that. Let me look here. Let me switch to the Blackboard page. Okay, so here's the Blackboard page, and so many of you have probably already seen that, right? Okay, so there's just the first announcement. Some announcements, I probably maybe putting some announcements in Blackboard, but some announcement may be in Webassign. So Madison might be putting announcements in Blackboard because I think she can email you more easily through Blackboard than through Webassign. But some announcements will also be put in Webassign as well. There's a similar, you know, place for announcements in Webassign. And you'll probably be looking at Webassign more than Blackboard since you'll be doing your homework in Blackboard. But anyway, there's the announcements. I did want to point out, of course, that the class syllabus is in Blackboard, right? Here's where the class notes and videos are going to be posted. So hopefully within a day of each class, I'll be posting the notes and the videos, right? So here's where the links will be. And I'm very meticulous about sample tests because, again, as I mentioned, sometimes our sometimes our questions on tests are a little bit conceptual and slightly different than the homework. So I like to give you a nice sample test. So this is where the sample test will be posted, but of course there's no sample test there yet, and because we won't have that until the first test. And then this is where the actual test will be posted itself, and then the answers to the test after the test. Okay, so those are kind of the key links there that you'll be looking at. There's lots of other links here that we may mention here from time to time, but those are sort of the importance. The syllabus, right? So you probably already found that already. Here's where the class notes and videos will be, and then the sample tests, and then the tests, right? And then sometimes announcements here in Blackboard. But we'll rely on Blackboard a lot less than Webassign because you'll just be going to Webassign all the time to do your homework, right? So you'll be in that portal a lot more than Blackboard. I do want to point out though, try to avoid sending me messages in Blackboard because I often do not see them. Blackboard does not, unfortunately, send me an email when you post a message. And sometimes I forget to look for the messages in Blackboard. So you will be safer emailing me directly to my email address rather than sending me a message, or send me a message through the Webassign message system, because the Webassign message system will send an email to me when you send me a message. So, and that I will see. Okay. So in general, I would avoid using messages in Blackboard. I don't have it turned off, but it's not a reliable way of communicating with me, right? Okay, so just a warning about that. Okay, I think, however, you may be able to email your classmates through Blackboard. So if you're trying to communicate with your classmates, you might want to use the UHD email through Blackboard to communicate with your classmates, right? Okay. All right. So so here's the Blackboard page. Are there any questions about that in particular at the moment? There's not much there yet, so there's really no opportunity yet for asking questions. Did I hear someone?
Yes, Professor. A quick
Yes.
question for you. So you said you recommend contacting you through our Gata email directly to the email you
Yeah,
posted?
through the Waller W email. That's
Gotcha.
going to be safer. Or you can message me through the Webassign message system. You'll see that when you're in Webassign. There's an option for sending a message to your instructor. And the reason that's more reliable is when you send me a message through Webassign, Webassign sends me an email saying you have a message in Webassign. And so then I think to look at the message, but Blackboard does not. I don't know why, but Blackboard does not do that. Okay. So if you use the message system in Blackboard, it's I may not see it immediately. So that causes all sorts of confusion, later on in the course. So just try emailing me directly at whatever that wallerw@uhd.edu. Yeah. Okay. Now, probably the main way you're going to be messaging me, though, okay, is by asking me questions. So let's go back to let me go back to Webassign here. It's logged me out. So let me log back in. And let's take a look at Webassign here just briefly. So I'm logging in. Let me go to this class. Now, this is my portal, so this is, you're not going to quite see what I'm seeing, but we'll switch to the student. Oh, see, 14 students have already registered. Yay, so y'all been doing that while I'm talking, okay? Let me open the student view so you can see what you're going to see when you log into Webassign, okay? So if you get registered there, enrolled. Registering is when you pay for the class. Enrolling is when you just enroll in this particular section. Here's sort of what you see, right? Here are the first couple of assignments, correct, right? The first assignment that it's due a week from today, so I've already got a due date on this one, is entering answers in Webassign. So that's just practice in how to actually use Webassign. If you've already used Webassign, you're going to find this a little bit boring to go through, but that's just how to enter answers. And then the first sort of real math assignment is this one, which is this algebra review, which is due 2 days later. This is just a review of skills from algebra, right? Okay, solving equations and simplifying expressions and those sorts of things that are skills, right? That I know you know, and just want you to brush up on them, especially if you haven't taken math for a little while, right? Okay, just things that just algebra skills, so you won't be making algebra mistakes on your homework or on the test, right? Okay, so that's just meant to be a review. I've got that. It's due a couple of days later. Most of the times I have the homeworks due at midnight, right? Okay, almost always, except on a test day. Sometimes the homeworks may be a little bit due a little bit earlier, but usually they're due at midnight. When we get closer to these due dates, I'll just see how y'all are doing in the class. I may have to adjust them. The due dates, if people are slow for some reason, but remember, you always have that option, right, to request an extension. Over here on the right hand side is the announcements, right? So I'm often posting announcements here instead of in Blackboard. So take a look at the announcements. Some of these are just generic announcements, though, about my email address and my office hours. and where you can find the class notes and where you can find the lecture videos. And there's the instructions for requesting an extension to a due date on a homework, right? So there's how you go through that process, right? In Webassign, okay? In looking for your grades, there's where your grade is going to be. So you just click on this, my total, and it will show you, what your current grade, actually it'll show it to you right here, right? What your current overall average is for the class. But if you click on that, it gives you more details, right? Okay. So it gives you more access to the grade book, so you can look at better at specific grades. This is just your overall average. So right now I'm averaging 0, right? Okay. Makes sense, right? Because we haven't done anything yet. I did create a discussion forum for the class. So this is unmonitored. So if you want to post messages to that discussion forum, hopefully someone will see them and maybe respond to you. Okay, this is just for the class, but I'm not going to monitor that. So that's sort of my promise to you. I won't monitor it. So if you're discussing things that you don't want me to see, that's fine. I'm not going to monitor it. All right. Okay. So that's meant to be for you to use. All right. As you wish. Okay. All right. So I'm going to back out here of Webassign now, and let's try to create an account and see how far we get with that process. Okay. But before I do that, do you have any immediate questions that you want to ask? Okay. Before we take a look at that, we've run about 50 minutes now, so let's take a break here for a few minutes. All right. So we'll take about a 5-minute break, and then we'll come back and we'll take a look and see if we can log on to Webassign, or if we can enroll in Webassign. See if I can remember how to do that, and then we'll start with the lecture. Okay. But before we get into that heavy lecture stuff, we need to relax here for a moment. So let's take about 5 minutes. So I'll start again at, I have 12:22, so we'll start again at 12:27. Okay, is that all right? Everyone fine with that? Okay. Okay. All right. So yeah, if you just insist on keep going, let me know. No? Okay. All right. All right. So I'll be back in 5 minutes. All right. Okay, so I'm back. Are y'all back?
Yes.
Okay. All right. So if everyone's gotten back, this is when I went to webassign.net, this is what I saw. Okay. So and so right there is the enter the class key. So so if you get to this screen on webassign.net, let's see, let's go to enter class key, and oh, that wasn't what I was expecting. Okay, so so you may have to create the account first. So this may not let me. Oh, here we go. It did. So what was that? What was that class key now? Can someone tell that to me? So y'all gave it to me a moment ago in the chat there. Let's see. There it is. So UHD 796. Whoops, 796.
7976.
Oh, yeah, 79769040. Okay, let's see if that will do something. So I'm not actually going to confirm the registration here, because otherwise I'll show up in my own class as a student, which I don't want to do, right? But I think if you it found it, right? So if you confirm to register there, I'm hoping that will take you to the right place. Okay, so whoops, let's so I hope everyone got admitted there. Okay. All right. So again, that looks like that's the right, at least getting us to the right location, that class key. Did that whoever asked me that question, did you see what you did wrong, or?
Yeah, the first time I just copy pasted it and it didn't really work out, but then I actually went and typed it in and it found it. So yeah, I got it.
Oh, I see. So maybe it's got maybe there was some trash in the cut and paste, or who knows, right? Or maybe it's got security where it won't let you cut and paste for some reason.
Maybe.
All right. So okay. All right, groovy. All right, so yeah, it looks like most people are getting registered, getting enrolled. Okay, right. And again, you've got a 2-week window there, right, before you actually have to pay, right? So you can go ahead and enroll in the class and start working immediately, right, on that first assignment, which is due a week from today, which is just practicing how to enter expressions and how to use the Webassign system. Some of those questions are a little bit, they're not mathematical, but some of them are a little bit challenging, just trying to learn to use the gadgets there that are in Webassign. But we don't usually have that. Most of those gadgets we won't be using. Most of the time we're just entering mathematical expressions. All right. Next on Thursday, we'll actually take a look at that first substantive assignment, which is the review, and we'll do a couple of problems off of that. I do want to caution you that sometimes Webassign is very picky about how answers are entered. So so I did want to kind of alert you to that. That's one of the frustrating systems of that's one of the frustrating things of using Webassign that you just kind of have to accept. Okay, but once you get practiced at that kink, at that quirk, then you'll get much better at taking your answers. Okay. All right, so I'm going to close Webassign now. If I can find the This will let me do that. Let me close this tab, and I'll also close the Blackboard tab here as well. And let me see if I can find our notes for today. So I'm going to go ahead and start in our lecture. All right. Oh boy. Okay. So if I can get stuff moved out of my way. We can start, as I mentioned, reviewing just some of the key concepts which you're already familiar with. So these are not going to be new things for you, all right, that we need, that sort of underlie calculus. And at the same time here, sort of gently here, sort of start squeezing in some of the key ideas from some of the early key ideas from calculus. All right. So I'm going to just launch into this now, right? As I mentioned, the first part of calculus is called differential calculus, and that's where we study relationships between quantities, and in particular, we're going to study how when one quantity changes, when you have related quantities, when one quantity changes, how does the second quantity change? Okay, so that's a real important topic here in differential calculus, or that is the key topic in what's known as differential calculus. Now, at first, that seems like kind of a mundane thing to study, but it turns out that that's really crucial in helping us answer lots of important physical questions. Okay, and it'll take a while for you to develop an understanding of why studying the change between quantities is so important and how useful it is. But don't worry, we will get to. Don't worry, we'll get to that. Okay, I'm going to here stop now while I'm writing on the screen. I'm going to stop my video, so you don't need to see me while I'm writing, because I'm going to have to bend over the screen, and that gets a little bit awkward in terms of the camera. If I can get the control panel back up. All right. Okay. So so here's a real simple mathematical definition. Okay, and that's the definition of a relation. And because again, we're studying in calculus relationships between quantities. Okay, but this definition at first glance doesn't really seem to lend itself to studying the relationship between quantities, but in fact it does, as we'll learn. Okay. All right. So this is a very abstract definition from mathematics. A relation is just a set of ordered pairs. Okay. So there's our very first definition in the class, right? A relation, a set of ordered pairs. So what I mean by ordered pairs, well, you're really familiar with ordered pairs. Okay. Ordered pairs are just a pair of numbers in parentheses, right? Okay, and they have an order to them, so that means that there's a first number in the pair and there's a second number in the pair, right? Okay, and usually we identify the first number and the second number, right, by reading the pair from left to right. Okay, so you usually think of ordered pairs as being coordinates for points. Okay, and that's fine to think of ordered pairs that way. All right, but they really don't have to be. Ordered pairs really don't have to be coordinates for points, right? It's just a pair of numbers that are grouped together. Okay. Now that's an ordered pair, but remember, a relation is a set of ordered pairs. Okay. So what I've written down here in example 1 are just a couple of simple relations. All right. Just 2 sets of ordered pairs. Okay. Relations are not limited in the number of ordered pairs that can be in the relation, the number of ordered pairs that can be in the set. So you can have lots of ordered pairs in the set, or you can have just a few ordered pairs in the set, right? Okay. In these two relations that I've written down here in example 1, they happen to have, let's see, 1, 2, 3, 4, is it 6 apiece, right? Each of these relations have 6 ordered pairs in them, but it could be fewer than 6 ordered pairs, or it could be actually infinitely many ordered pairs in each set, right? Okay. The number of ordered pairs in the set is not important. As long as you've got a set of ordered pairs, then you have what's known as a relation, right? Now, since relations are sets, right? Since relations are sets, we can use set notation, typical mathematical set notation, to indicate the set, right? So I'm going to write braces here to indicate that we have a set, right? A set of ordered pairs, a relation. So that's why I put a brace here around each of the ordered pairs, correct, right? Okay. And, often in mathematics, we like to give sets capital letter names. So I just, for fun here, gave these two relations capital letter names. So this first relation I'm calling A, and the second relation I'm going to call B, okay? Very creative names, right? Just A and B there, all right? Again, in each one of these sets, right, you have ordered pairs, right? So here's your first ordered pair, -2, 0. Here's your second ordered pair, -1, 1. Here's your third ordered pair, -1, 1. This is -1, -1. The third ordered pair is -1, +1, and so on and so forth. And then C and B, right, you also have a bunch of ordered pairs in this relation as well. Remember, in each of the ordered pairs, right, there's an order to the number in the pair, correct, right? So if you switch the order of these two numbers in this pair, you get a different ordered pair. That's important, correct? So if I put 0 first and -2 second, that's a different ordered pair than a -2 first and 0 second. Now, the terminology that usually surrounds ordered pairs. You're familiar with that already. So this first number in the ordered pair, we often call that the first coordinate. And the second number in the ordered pair, we often call that the second coordinate. Sometimes we call the first number in the ordered pair the x coordinate. And sometimes we call the second number in the ordered pair the y coordinate, right? Okay. Coordinates are usually what we call the numbers themselves that are in an ordered pair, right? So lots of ordered pairs here in the relation A, 6 of them, in fact, lots of ordered pairs in the relation B, 6 of them as well. Notice here I put a question here, right, for you. This is just kind of a summary question. And the question here is, how are these two relations different? Obviously, they're not the same relation, right? Because they don't have the same ordered pairs in them. But are there other sort of reasons why these two relations are different? We're going to come back to that question. It may be in a couple of lectures, right? What makes these two relations different from one another, other than the fact that they have different ordered pairs in them, correct? Right? Is there some other difference in these two ordered pairs? Notice it's not in the, by the way, notice it's not in the size of the set, right? Because both of these relations have the same number of pairs in them, right? 6. So that's not a fundamental difference between A and B. But is there some other difference in these two relations that you can spot? Okay. All right, now, okay, so relation is a very abstract definition, right? So we have to kind of tie that back to the real world, right? Okay, because remember, calculus is about studying the relationship between quantities, right? Okay, and usually these are real world quantities, correct? These are quantities that come about from measuring something in the real world, correct? So how do we take this very abstract definition of relation, and how do we, sort of put that into, kind of a real world context, right? Into a more practical context. Well, let me show you one way that we can do that. So this is the second example here, right? So what this example shows is a set of matching data values here, right? Okay, and what it shows is that the price that you're going to pay, or the price you're going to pay at a particular gas station for a certain amount of gas. Okay, so this is just kind of a table of prices here for a gas station, right? So in this table of data, right, notice if you buy 2 gallons of gas at this gas station, you're going to pay $3.60. If you buy 4 gallons, you're going to pay $7.20. If you buy 6 gallons, right, you're going to pay $6.80, right, and so on and so forth, right, up to if you buy 12 gallons, you're going to pay $21.60, right? So so notice that this table does show you here a relationship between two quantities, right? It shows us the relationship between the amount of gas that we purchased and the price that we're going to pay for that amount of gas, right? And both of these quantities that can change, it can change, right? Different people are going to buy different amounts of gas, right? And of course, if they buy different amounts of gas, right, they're going to, of course, pay different prices, right? Okay, so here's a situation, right, where we have two physical quantities, and where the quantities, right, will be changing, correct? The amount of gas purchase will change, right, from customer to customer, and the amount of of course paid, right, will change as well, right, when the amount purchased, right? So see, here's a table here that shows a relationship between changing quantities. Now, this is just a table of data, right? But again, why is this the same, or why can we think of this table as a mathematical relation? Remember, a relation is just a set of ordered pairs, correct, right? Well, that's easy, right? Each one of the rows here in this table, correct, right, which shows amount of gas and the price paid for that gas, right? Notice we can convert each one of these rows into an ordered pair, correct, right? So this first row, instead of writing it out the way it's written in the table, correct, we can write this out as the ordered pair 2 and 360, right, and so on and so forth, right, for each row in the table. So see, we can take this table of data pairs, right, and we can convert them to a set of ordered pairs. And whenever you have a set of ordered pairs, you have a relation. Okay, so see this table of matching data values, the matching, or I should say related data values, right? We can convert this into a mathematical relation, right, by just taking each row and writing it as an ordered pair, right? So so here is a sort of information that you might see presented frequently, right, in practice or in the real world, right? And notice that we can think of that in a mathematical sense as a set of ordered pairs. Let me show you a little bit more complicated set of data, right? Okay, which is similar to this first set. So, you know, often when you go and buy gas, right, you'll get a cash price, right, and then you'll get a credit price. Oh, I wrote this. I wrote this backwards. Okay, let me change my table a little bit here, because usually the cash price is less than the credit price, right? So let's change the description here of our columns here in the table. All right. So so this table, right, shows also relationships between quantities that change, right? Okay, again, amount of gas purchased, right? But this table shows both the price you're going to pay in credit, right, but then also the price that you would pay in cash, which in this case is a little bit less, right? Okay, and again, we can think of this table of related data values as really being relations. Okay, actually, two relations here. The relationship between the amount of gas and the credit price, right? So you can write that as this set of ordered pairs. All right. Not going to write all of the ordered pairs down, but you can easily take them out of the table, right? So there's the set of ordered pairs, right, that that we can draw from or create from the amount of gas purchased and the credit price, and then we get a separate set of ordered pairs, right, from writing down the cash price, right, for each amount of gas purchased. So this table of related data values really encompasses two relations, right? Okay, the relationship between the amount of gas purchased and the credit price, right, and the amount of gas purchased and the corresponding cash price. Okay, so here we have two relations. And again, if we wanted to, right, we could give these two relations capital names. Let's see, we could call this one, it's not the name I wanted to use. Maybe we could call this one R for credit. And maybe the second one here, if I can get to that, we could call that C for cash, right? So my point here in these first couple of examples is just that mathematical relations often appear in practice in the real world. Okay, we just don't often think of real world examples in sort of abstract mathematical terms, but we can if we ask ourselves to do that, right? Okay. So our abstract mathematical definitions really do have, real world instances, right? Now, let me show you another example of a object that can be thought of as a relation. Okay. All right. So here's example 4, and in this example, it says graphs of sets of points are in fact mathematical relations. Okay, so here's a graph of a set of points. This graph is going to model the jail population in the United States. Okay, so it depicts the jail population in the United States a given number of years after 1900. All right, so if you look at the graph, I want to point out that the numbers here plotted on the horizontal axis here, this is years after 1900, right? So 80 would correspond to 1980, or 85 would correspond to 1985, up to 115 would correspond to 2015. So that's the last year that we have in the graph is 2015. So the graph's a little bit out of date, right? Okay, and then the values here plotted along the vertical axis, right? Which I've labeled here as Y, as you normally would. This gives you jail population here in millions. All right. So notice when you look at that graph, right, you can immediately glean information about the relationship, right, in these two quantities, right? That is the elapsed years from 1900, that is time, right, and the jail population. What's the first thing you notice there about the relationship between the jail population and time? If I ask you just to comment on that graph, what would you sort of say that graph is telling you about the jail population? Anybody want to make a suggestion to me there? Yeah, that's right. It's increasing, right? Okay, that's the first thing you're going to notice, right? Okay, over time after 1980, right? Of course, the jail population is increasing, correct? Up to a particular point, correct? Right? To it looks like about what year is that? If we can read that, sometime between 2005 and 2010, right? Okay, and then after that, notice at least till 2015, right? Notice that the jail population was decreasing, right? So see, by looking at this graph, right, you already there, you're getting some suggestions, right, about how the jail population is changing, correct? How that quantity is changing as the time as the year is changing, right? Okay, see, this is something that we're concerned with in calculus, right? How one quantity changes as a second quantity changes, and you can immediately see that from the graph, right? So pictures are really fabulous tools for us, right? We can immediately say, yeah, okay, the jail population was increasing, but now more recently it's been decreasing. Now, why is it though that this graph is a mathematical relation? Remember, what's a mathematical relation? It's just what? It's a set of ordered pairs. So why is this graph nothing more than a set of ordered pairs? Well, a graph is nothing more than a bunch of points, right? Okay, so a graph is nothing more than a set of points. But you know, when you have a set of points, each one of these points has coordinates, correct? Right? Each one of these points has a first coordinate, a horizontal coordinate. Usually you'd call that the x coordinate, but here, since I labeled this axis as t for time, this is the t coordinate, and then each one has a y coordinate, right? A second coordinate. So every point on your graph has coordinates, and you can write down those coordinates, right? I've only written down a couple of them. The first point on the graph and the second point on the graph. We might also try to write, let's try to write down the coordinates for this point as well, since that's an important point on the graph. Let's see, what does that look like to you guys? Can y'all read that? It's hard for me to read it here looking at it. So that looks like, I'm thinking 109 for the first coordinate, and for the second coordinate, is that close to 8? Pretty close to 8, right? So there's the coordinates for that. There's the coordinates for that second point, right? Okay, I mean for I'm sorry, yeah, there's the coordinates for this third point. Well, if you do this same process, right, if you write down coordinates for each one of these points, that would take you a while, correct? But if you wrote down coordinates for each one of these points, what would you come up with? You would come up with, if you wrote them down on paper here, you would come up with just a big set of points, right? Just a big set of ordered pairs. I'm only going to write down a few of them. So you would have 80 and 2.5 and etc. here. And then you would have 109 and 8, the one I just put down, right? And then so on and so forth, right? Up to eventually you would have that last point there, which looks like 115 and 7.5, right? So if you were patient enough, right, and able to write down all of the coordinates for all the points on this graph, what you would end up with is just a big set of ordered pairs. So you see this graph also is a relation, correct? Okay. So graphs of sets of points are another way that relations often express themselves in practice, okay? A graph of set of points is nothing more than a mathematical relation. Now, here's another way that you often see relations expressed, okay? And this one is going to be important to us as well in the class. And so notice in example 5, we have that solutions to equations that have two variables in them also are relations, okay? So solutions to equations with two variables, this is a little bit more complicated than the first two, so we have to read this carefully. So solutions to equations that have two variables in them, I claim also are relations, right? Okay. Now, why is that the case? Well, we need to look at an example. So let me scroll down here and let me give you another example. All right. So here's an equation that relates the life expectancy for female high school dropouts. All right. So life expectancy for female high school dropouts. And again, so we're going to call that number Y, their life expectancy. We're going to refer to that as the variable Y. And then this is X elapsed years after 1990. Okay. All right. So that's what this equation relates. Life expectancy Y to elapsed years after 1990. Now, to understand this definition completely, I need to write down some solutions to this equation. Okay, so notice this is an equation with two variables in it, right? And this X is elapsed years after 1990, and Y is the life expectancy, okay, of high school dropouts. Notice that's high school, not graduates, but high school dropouts. So these are females, by the way, who did not graduate from high school. Okay, all right. So notice both of those quantities are in this equation, and they're related by this equation, right? Okay. All right. So here's my first question for you. What does it mean to write down a solution to an equation with two variables in it? So mathematically, what does it mean to create a solution to an equation like this one? Someone care to tell me that, or you can type it in if you like. Okay. So what's a solution to an equation with two variables? When I solve an equation for two variables, what does that mean? Anybody have an idea there? Or let me ask the question differently there. Can you give me a solution to this equation? So without describing in general what a solution is, in general, can you tell me a solution to this equation? So can you give me a solution to this equation? Oh, here's what Van Tran suggests. Van Tran says, plug in for one variable and solve for the other one. Okay, Van. So that's kind of a good suggestion. Plug a number in for one of the variables and solve for the other one. So can you give me a little bit more detail there? What should I plug in for which variable? Oh, I see. So Van says, try plugging in 0 for X. All right, so let me write this in my table, 0 for X. And when you plug in 0 for X, let's write this down. So you have 0.22 times 0 plus Y is equal to 78, okay? And well, 0.22 times 0 is 0, right? So we get here Y is equal to 78. Is that what you were looking for, Van? I think so, okay, because that's what he indicates. All right, this is what I mean by a solution to an equation with two variables, okay? When you write down a solution to an equation with two variables, you mean a value for X and a value for Y, so that when you substitute them into the equation will be true, okay? All right, and that's definitely true in this case, correct? Because if you plug 0 in for X and 78 in for Y, well, you're going to get 78 equals 78, correct? Okay, which is true. All right, so that's what we mean by a solution to an equation in two variables is a number for one of the variables, a number for the second variable, so that when you plug them in, you make the equation true. Okay, by the way, what is this? So this X equals 0, Y equals 78. notice that is a solution to this equation. By the way, what is this solution to the equation telling you about female life expectancy for high school dropouts? So what is that? What does that solution to the equation mean to us? X equals 0, y equal 78. Can anybody interpret that solution or tell us what that solution means in the context of this problem? X equals 0, y equals 78. Y'all are very quiet, so I know someone there knows what that means, though. Okay, right? Oh, here's a good suggestion. Those who don't drop out live to be 78. That's a really good try, Zamir. Okay, but not quite correct. Okay. This is getting closer, right? Okay. If someone were to drop out in 1990, then they would have a life expectancy of 78 years. That's sort of correct. Okay. Not quite, but almost correct. What this tells us is that in the year 1990, okay, in the year 1990, because 1990 is 0 years after 1990, right? So in the year 1990, the life expectancy for female high school dropouts was 78, okay? So in that particular year, 1990, that was at that time, that was the life expectancy for female high school dropouts, okay? So in that particular year, if someone had, if there was a woman there who had dropped out of high school, it didn't have to drop out in 1990, just at any point, right? If she had dropped out of high school, her life expectancy would be 78, okay? Now, of course, you know, what we're often interested in is our life expectancies going up or our life expectancies going down, okay? And we're particularly interested in that for certain subpopulations because that gives us an idea of how well that subpopulation happens to be doing, okay? Of course, financially or health-wise, right? If a life expectancy is going up for some subpopulation, we think of that as being good, okay? That probably means that, of course, that the subpopulation is healthier, probably means that they're wealthier as well, okay? If the life expectancy is going down, then that's not as good a picture, all right? So see, what we're interested in here is, again, is how is the life expectancy changing, right? How is life expectancy changing as time goes by here, right? Okay, after 1990. So we know in 1990 that corresponds to X equals 0. The life expectancy is 78. Okay, all right. Well, let's see what's happened here by finding some more solutions to this equation. So how can I find more solutions to this equation? See, we found one solution here by plugging 0 in for X and then figuring out what the Y is. How can I find more solutions to this equation? Yeah, substitute different values for X, right? Okay, so let's try a new value for X here. Let's try 10, all right? By the way, 10 would bring us to what year? Yeah, that's year 2000, right? Okay, so let's see what happens in the year 2000, all right? So what we'll do is plug 10 in for X, and then we're going to solve this equation for Y. In other words, I'm going to figure out what Y value will match with X, right? Okay, to give us a solution to this equation. Well, that's pretty easy to do by hand. We have 2.2, that's 0.22 times 10, right? Plus Y is equal to 78. And now to solve this equation, just subtract 2.2 from both sides. Let me see if I can get my pen to write. Okay. There we go. So Y would be equal to 78 minus 2.2, right? Which is, if I'm doing my math correct, is that 75.8? Did I do that right? I hope so.
You did.
Y'all better stop me if I'm not doing it right, and I will make mistakes. So so y'all have to be sure you help me with mistakes. Ooh, this is a bad sign. What's happened from 1990 to 2000?
Life expectancy decreased.
Yeah, the life expectancy dropped. Okay, so what that tells us is female high school graduates not doing as well in the year 2000 as they were doing in 1990. Their life expectancy has dropped. That's not a good thing. Okay, not a good thing. Okay, that means life has gotten tougher for female high school dropouts. But we can speculate as to the reasons for that, right? Okay, but probably because they are going to have a harder time finding well-paying jobs, right? Because we know now that jobs have become highly dependent on education level, correct? Okay, and so probably these people in 2000 not securing as a good a job, right? Maybe not with health insurance any longer, right? And maybe that's contributing to a drop in the life expectancy. Let's run this forward now to 10 more years. Let's see what's happened in 2010. So if I put 20 in there, right? Again, we go through the same process, just plug 20 in for X, correct, right? And then solve for the matching Y value. And I think that's going to come out to be, we can almost predict it here. It's going to come out to be 73.6. So see, the situation has even gotten worse, right? Okay, the life expectancy has dropped more in these 10 years, right? So see, that's something for sociologists or healthcare experts would be keenly interested in knowing why is that life expectancy dropping, right? And in particular, what could we do to stop that life expectancy from dropping? Because that's not what we want to see happen, okay? So notice then that the solutions to this equation, right? When you start writing down the solutions to these equations, what do you get? You get a table of matching data pairs, and of course, that is a relation, right? Okay, because you can think of each of the matching data pairs, right, in this table as being an ordered pair, and so you have a relation. And even better, you can think of these ordered pairs as being points, so you can graph this equation, right? Okay, so let's try making this graph here. So I'm just going to plot each one of these ordered pairs as points, right, on a coordinate system. So I've already drawn the coordinate system here. I've already plotted the first point. So there is 0 and 78. Let's see, what was the next point? 10 and 75.8, right? Which would be maybe about right here, maybe. And then the next one was 20 and 73, somewhere down here, okay? So you can actually plot the entire equation, right, by, I didn't do it very well, so by connecting these, the three solutions that we got here, right, with a curve, and the curve that's suggested here, of course, is a straight line. If I can get my pen to draw for me, which I cannot. There we go. All right, so so if we graph this, all the solutions to this equation, right? Notice we're going to come out with a nice graph here. In this case, we're going to get a straight line, okay? But not a straight line that we really want to see, because this straight line is decreasing, right? The life expectancy for female high school dropouts is going down, right? So that's that change there is a disturbing picture to us. Okay, all right, so well, we didn't quite make it through all the notes today. I'm not going to try to go to the next example, but we're going to pick up with that next time, but we've run out of time today, okay? So you've learned there kind of three basic facts, all right? are 3 or 4 basic facts here. You know what a relation is, just a set of ordered pairs, right? But you know now that relations can present themselves to us in mathematical relations can present themselves to us in lots of different ways, right? One way is through graphs of sets of points. One way is through equations. And then another way is just through tables of data pairs, right? Okay. And we're going to see in this class relations occur in all 3 of those ways in calculus. All right. So do y'all have some questions right now that you want to ask me before we stop here?
Prof, could you scroll up a little bit to example 5? I didn't get to write down what was next to it.
Right there.
Right there. Yeah. Thank
Yeah.
you.
So again, I'm going to post the notes for you. So this will be on the Blackboard page. There's a section there that says class notes and videos. And right here, when I finish the class, I'm going to see if I can upload the video. All right. Okay. To YouTube. And then I will try to post the link there, but that may take me a little while. So it might be tomorrow before I get, but all the notes will be eventually posted on the class Blackboard page. Okay, so you don't have to slavishly write everything down. You can find it after class. Students often ask me, can I post the notes before class? I'd really like to be able to do that, but that's really hard for me to do because sometimes I don't have them ready in time to post them before class. So unfortunately, I cannot have them ready for you to just write on while we're doing the class. That would be ideal, but that's not always possible. Other questions here? Okay, so next time we're going to pick up just where we were, and we'll also look at next time one of the Webassign assignments, probably the second one that's already posted, just to play with that a little bit, just so you can see, filling in answers. But you may be ahead of me by that time if you've already started working on those, if you've already gotten enrolled in the class and started working on those assignments, okay, before next time. All right, so I'm going to sign off with that. Is Madison still there?
Yes, sir, I'm here.
Okay, so again, remember there's Madison, and she's going to be in touch with you sometime this week, right, to poll y'all on when you want to have your SI sessions, okay, right? So she may be, I guess, you're going to email. So you may be posting in Blackboard, I guess, right? So
Yes, sir.
yeah, okay. So so she'll be emailing you that way. All right. So it was great. We didn't get a chance to meet all of you next time. Ooh, I've got to work on that. Also, at the start of class next time is us getting a little bit more familiar with one another. I just chatted with a few of you here today, but I do want a chance to meet all of you or talk with all of you once here, right? Okay, at least at the start of the course. So we'll be familiar with each other. All right. So unless there's other questions, I think we're free to log off, and I will see you again at the same time on Thursday. Okay. Thanks for everyone's help, everyone's input.
Thank you. You have a good day.
All right. Bye. All right.
It was nice meeting you guys.
Let me stop the video.